Hey everyone, so I wanted to cover my reverse osmosis water maker system while I'm waiting on my pickup here today. I just did 4 days on Laguna Madre. I wanted to do longer, but weather's rolling in, so I'm getting plucked out a little bit early and waiting on my ride now. So I use this system to make fresh drinking water on my kayak. And first, you might say, well, that seems a bit extreme for a kayak, but if you think about it, yeah, it costs more, but I can make more water than I can carry using this system. So, um, minus the battery, this whole system weighs roughly 40 pounds. It's like 42. 5 gallons of water weighs almost exactly the same. So, volumetric wise, it's not terribly much bigger than what would take 5 gallons of water. If you think of a 5 gallon bucket, it's not a whole lot more than that, and the weight is almost identical. So, but I can make an infinite amount of water with the battery and a solar panel, which I put solar panels on my kayak. So I could essentially make an unlimited amount of water. Well, I mean, I'm limited to 100,000 gallons on the filter inside of here. So to each his own. This is version 1.0. I'm going to try to reduce it and get the size smaller. I want to try to change the pumps. There's some options, I think, for smaller filters. This right here is 14 pounds. If I could get this down into a smaller setup, just this right here is 14 pounds. If I could get that into a smaller form factor, it can cut some weight there. I think I can cut some weight here. And this is a 21-inch filter. I think I can, there is a 14-inch version of this. I think I could get this down to. So I'd like to, compact it. But for now, this is what I've got. And I'd also like to go to a DC pump, which would eliminate having to have an AC inverter hooked up to a battery. I could just run this directly off of a battery. So anyway, first I'll talk about reverse osmosis, exactly what it is and how you can turn salt water into drinking water. I'll be real brief on that, and then I'll go start on the low pressure side and I'll work my way over to where the clean water comes out. So first of all, what is reverse osmosis? That is the process of turning contaminated, dirty water into fresh drinking water. So reverse osmosis means you're pushing something through a membrane. In this case, the high pressure comes in on this side, goes through. Inside of this membrane housing is a filter, and down the middle of that filter is a tube. So you use this to put a high pressure around that tube, and it forces clean water through, but the salts can't make it into that tube. And so then the water that can't make it through ends up getting flushed out. It's a continuous process. It gets flushed out the port up there, and that's your brine water or your brine solution exit port for the dirty water. And then the clean water comes out the secondary port, which is behind here, and is connected to this tube, and that water comes out at a rate of about 10 to 20% of what's going in. So meaning if you push 10 gallons through here, you're going to get between 1 to 2 gallons of fresh clean drinking water. So that's reverse osmosis in a nutshell. Works really well. I've been really happy with it, other than obviously the weight and the size of it. But so to start over here on the left side, and we'll work our way this way. First up, you got your mesh filter in here. This is a stainless steel filter inside of here. That gets out your jellyfish, your little sea creatures. That gets out the grass. You can actually see some grass in there, which was my biggest problem out here. And then that comes up through this. I got these flexible hoses off of Amazon. I really like them. They're called Flexzilla, and it's a good brand. They don't kink even when you're turning, even when you go pretty far turns. I like these a lot compared to the real rigid ones I had before. These are amazing and really made getting these things into position a lot easier. So coming up to that, you got this pump. It's just a low pressure pump. It's got a max of 65 psi. I don't know that it really does that, but on this side of the pump is your low pressure side. This side is your high pressure side. So it keeps all of this charged to about 60 psi, and that makes it so that this pressure washer has a good supply of water over here. So once it goes through the pump, it hits the first pre-filter, which is a 20 micron filter, and you can see it's pleated, and it's pretty dirty already. I've made about probably 10 gallons of water total out of salt water on these, and some of the conditions out here were terrible. I mean, I was in almost straight muddy water. It was pretty nasty, but I needed water, and there was no other option other than to kayak out, a half mile and drop that in. So I was doing most of it on the shoreline at night and in the mornings, and so I typically mucky water, especially I'm stomping around in it, and so that's why they look pretty bad. The 20 micron one I think you can take out and wash off. I didn't read the details on that. I just brought a spare, but it's still producing right now perfectly fine even the way it is. I think I could take that out and rinse it off and it would be fine, but So anyway, that goes into the 5 micron filter, and this is just basically gets your finer sediments out. So these sediment filters work really well. Obviously, they're both kind of, you know, used up a little bit right now, but they're cheap too. They're only about $5 a filter. So this set right here is about $10. They come in sets of 4, and I brought 1 extra of each, and I got 2 more at home. Actually, I got 1 extra at home. The first time I put them in, I hooked everything up backwards, and so I kind of ruined the first ones, and so I chucked them. And this is my second set, and then I have a spare set with me that I haven't used yet. So from there, I put this split valve on here for a reason, because inside of the kayak I have a small hose that I connect to this, and it goes down into the kayak, and so that becomes my bilge pump. This is actually doubles as my bilge pump. So that's why I have a splitter on here, and I could close this side going to here, and I can open this side, and then that bilge water comes shooting out here. Alternatively, I could also put a sprayer on here. I could get a hand sprayer and hook a hose up to this, put this in the ocean, turn the pump on, and now I have a saltwater sprayer. Not very practical to be spraying salt water all over everything, but if you wanted to like hose off some fish guts or something, you know, it's there, it's an option. So that's why I put that there. And that's also why I added this part here. So the strainer and all these pumps, they don't come with all these little fittings and stuff. I have links for all the fittings down in the description, but even this brass fitting, there's a brass fitting between the housing and the splitter that you can barely see there. And so all of those fittings, you need all those, because these are 3/4 MPT, National Pipe thread, going into a 3/4 inch GHT garden hose thread. And so if you don't have the right fittings in here, you're going to be ordering more stuff and ordering more stuff. So all the links are below. You can check them out there. I've got every fitting, every filter housing, all this stuff is all down below. And if they go out of stock or whatever, I'll try to keep that updated. But that's just a note. Also, use Teflon tape. So Teflon tape was huge for these. First time I put it together, I just did like 1 or 2 wraps of Teflon tape, and almost every fitting leaked when I did it the first time. I went back and I did 6 or 7, maybe 8 wraps of Teflon tape, and then I wrenched them down pretty tight. First I was concerned about maybe cracking the housing, but I didn't. I'm not worried about that now. But yeah, 6 or 7, maybe 8 wraps of Teflon tape to keep these from leaking. That was kind of critical. And even then, I think it's still, I got a drip over there, but not too big of a deal it's in a kayak anyway. All right, so this just hooks up. I have a cable for this little thing here, which I basically have an extension cable which plugs into the front of my battery box, which is connected to this. So that's how I get 12 volts to this pump. That's pretty simple, pretty easy explanation. So then you get to the pressure pump. This is a Greenworks 1700 PSI electric pressure washer. So this, you can buy these at Lowe's. I got this at Lowe's for I think 80 bucks. I couldn't find a link to it to this exact one on Amazon, so I put the one that's very comparable to this. It's got the same connection, same rating, pretty much the same rating, pretty much all the same specs. If you want to just get it off of Amazon and not have to go to Lowe's, I think it was 90 bucks or 100 bucks on Amazon. But yeah, so it's pretty light. It's actually lighter than this. I think it came in at 13 pounds, and for just this, if you had the entire cable, which was about 20 something feet longer than this, I cut it down. I opened it up on the back here. I cut it so that it was only about 8 feet long, and then I just put the wires back in there. It was a pretty simple thing to shorten that one down, and then that shaved off probably 3 or 4 pounds. And then the same for the hose over here. I went to this whip hose instead of the longer one that comes with it, because that longer one is like 30 feet and weighs like 4 or 5 pounds. So just taking those two out of the equation, I was able to reduce, you know, probably 8 pounds off the load total, plus the bulkiness of all that extra stuff. But this is a triplex pumper. Triplex pump is what it's called, a triplex or a triple plunger pump inside of here. I did try to take it out, but it just made more sense to leave it in here with the protections that this kind of gives it, especially with an AC motor inside of here around water, you know. It's like a toaster sitting next to the bathtub kind of thing there. But even with the GFCI outlet. So I'd like to get this down to a DC pump of some sort, but I didn't have enough time to test stuff, and any DC pump that would work with even just the triplex pump part. I couldn't find one for under a couple $100. And then to try to marry that up with a DC motor, you were talking another $300 probably too, for a marine rated, you know, saltwater marine rated type. It was just getting extremely uneconomical. This is a $90 solution. I already had a $100 inverter that I thought would work with it. So I went and I bought this. I hooked it up to this to see if it would run off of it, and it ran fine, no problems. I was really happy with the performance, and so I was just like, well, I'm going with this now because I want to get this done before we get too far into the season, which apparently I did anyway, but that's not here nor there. It works well, but I'd like to get it to a DC pump of some sort to eliminate this, reduce the size, and be more efficient. So this draws, not that this is terrible, running off of a lithium battery, and I ran it all the way down until the battery was dead on one run, just to see how much I could get out of it, where this would cut off with the battery being pulled on this, and it ran forever. I was sitting out back and it got dark and I was still running, and finally the battery cut off. Lithium is the way to go. I would say it costs about 100 watts per half gallon to 3/4 of a gallon, depending on the water's dirtiness. So when I'm at home, I can make a gallon about every 4.5 minutes. Out here, I'm making a half gallon in about 3 to 3.5 minutes, maybe 4 minutes. So I didn't do a full 1 gallon test out here with the stopwatch and all that, but the point is it's very economical on watts. It doesn't take a lot of watts to make a half gallon of water. I got 3 100-watt solar panels. Even if you had one 100-watt solar panel, you could gather enough energy in an hour to make at least a half gallon of water. So that's pretty cool. Really like that. And I got other videos on the solar panels on the Kayak and the trolling motor and how it was all kind of worked together. That's part of my channel, so check those videos out if you haven't already. So next, after the pump, I think that's all there is to talk about with the pump. Like I said, it's connected to this inverter. It's a 1500-watt inverter. It turns battery power into your typical house power. So it inverts DC to AC. You got two wires on the back here, a red and a black, that go to the battery, and then on the front you plug in the pump. And that's really it. There was a bit of a challenge because I didn't want to leave this on during the day, so I would turn that switch off and then I'd turn that switch on, but then to get it turned on in the front, I had to push the button up here to turn it on, and I had it on top of the battery in the back under the solar panels, which is why I basically only made water when I was up on shore, because I had to get my hand under there. So if I could come up with a better way to turn all this on and maybe just flip a switch and like have water pour out like right next to me, would be awesome. But for version 1.0, this worked, and I was really happy with it, and just had these little workarounds and little things I had to deal with. But so moving on past the low pressure side, past the pump, I think that's all there is to say about that. Over to the right side is the high pressure side. And before I start talking about the high pressure side, if you would please give this video a like if you like these kind of videos and doing these kind of things. It was a lot of work getting all this together, and the likes really help the channel and encourage more videos and more things to do. And if you haven't already, please click that bell icon so you get notified when I drop more videos. I got the trolling motor video coming and the solar panel video coming with the electronics box and this and all that kind of stuff. So yeah, sub below. All right, on to the high pressure side. So this is an AMI, I believe is the brand name. I think the sticker's down here. It is a fiberglass housing, membrane housing. I think this was about $300, and then the membrane inside was roughly $200. So $500 for the housing and the membrane, and then all the extra little parts and stuff. I don't remember exact prices, but it's all listed down below if you want to look at that in the description. I think I actually put the prices in the description. You don't even have to go click to see what they cost. But anyway, the idea is on the end, and I'll disconnect this now. So just so you can see, on this end, there is one entry. I put a quick disconnect on here for the whip hose just to make it a little bit easier. I didn't want to have any kind of permanent connection there. And then there's a plug on this side. So there's 2 holes on that side, and then there's also 2 holes on this side. One is your discharge port, and the other is your clean water port. So I was saying earlier how you push that water in, and that goes around the filter, and then on the inside there's that tube. Well, this is where that clean water comes out. For the clean water that makes it into that tube, it comes out here. and then the dirty water comes out here and it just goes out this end. So all my clean water was coming out through here, and I would just put this into my bucket and let this go onto the deck and drain out the scupper holes. No big deal. With this needle valve, what this does is you start fully open, you turn the pump on, and then you slowly tighten it down, righty-tighty, and you'll watch this needle come up. This only does a half turn. Like this is full open, this is full close. So it only goes about a half, 3/4 of a turn. And somewhere right around here, you'd see it'll start coming up. Once you hit about 600, between 600 and 800, you'll start seeing a little bit of water start coming out of here. And by the time you get to 800, it's a pretty good stream of water coming out. It works really well. I was really happy with it, the way everything came out. So yeah, I don't know what else to say about that. That's kind of the system. It's a bit tricky getting the membrane filter in there and getting the ends all buckled down, but it's all doable. It's nothing too terribly hard. Yeah, so that's really about it. The only gotchas, like I said, was the Teflon tape. Go to 6 to 8 wraps, and you should be good on the Teflon tape. Again, I have links for all the description. I have links in the description for all of these parts and stuff. And there's also, I did a web page, solarkayaking.com. There's a page dedicated to this version 1.0. And like I said, I'm going to try to get to a smaller version of this. I'm thinking DC pump, eliminate this, smaller filters. I think there's some options that may work, so I'm going to buy some stuff over the winter. Yeah, so that's about it. If you got any questions, comment below. If you know, I would be interested if anybody knows anything about the DC pumps that you can use for this kind of application. If anybody knows of one that I could put together for under a couple $100, because I mean this is a $90 solution right here, or $80 at Lowe's. It was on sale, normally 100, but 80 bucks for this, and this was I think 120, so that's around $200. If I could get one DC pump and motor for about the same price, that would be amazing. I couldn't find one. I've even searched Alibaba, Global Sources. I went on a bunch of different websites looking for that solution. So if somebody's got that, I would love to try to put this into like a smaller form factor, maybe even like a Pelican case. And if I could get a DIY version of that into something that small, that would be amazing. And yeah, I would love to share that with everybody through the website. All right, that's all I got. Thanks for watching, and stay safe out there and have a good day.